Today we're reviewing the NVIDIA RTX 3090 Ti. $2,200 gets you this, and it also gets you one of these. We're at that stage now. We got the octopus cables going on. It's 3 8-pins for this one, feeding into a single 12-pin. We're gonna have a full teardown, obviously, but in this video we're focusing on the performance, to some extent the value, and we'll also be going over extensively the thermals and the design characteristics, how it performs overall. But the price is what you need to know right away. The cheapest ones of these we're aware of start at $2,000. Let's get started. Before that, this video is brought to you by CableMod's PCIe 4.0 riser cables, available in 90-degree and straight connections. The PCIe Gen 4 riser cables run up to 30 centimeters long and pair well with CableMod's vertical GPU brackets, designed to maintain a more optimal distance between the video card fans and the case side panel. CableMod markets that these have full-speed signal transmission because they use a pure copper tinning process to achieve better signal quality. Learn more at the link in the description below. The money angle is pretty known at this point for these cards. We've done the gag before. Now it's more of a power thing, though. The 3090 Ti is the most power-hungry card we've tested before overclocking. So we'll go over the numbers in a little bit in detail, but you're looking at 500 watts, plus or minus maybe 20 here. Doesn't help you a lot for the 3090 Ti, and that is drastically increased over the original 3090. What that extra power gets you, we're going to save everyone the time here and just give you the quick version up front, is somewhere between about 8 and 12% on average uplift over an RTX 3090 non-Ti, which we have been calling the business casual edition of the 3090, or the filthy pores edition, if you will, because the 3090 Ti is the business person's 3090. So the Ti is a 10,752 CUDA-core card versus the 3090 original card that's at 10,496 CUDA cores. Not a big difference there, a couple percent. It's a non-linear increase in performance for CUDA core increases because there are other factors at play too, like base and boost clocks, ROPs, TMUs, the memory bus, the memory controllers, the amount of memory, all that stuff factors in. But that's the change just for the GPU core and the CUDA core count within it. So anyway, the pricing was mostly hidden up until the last minute for this one. The whole launch was actually pretty last minute from NVIDIA, where the card showed up on Friday for us. We started testing immediately. The review goes up now, and so that means we had basically all of Saturday, Sunday to produce it, and Monday to produce it. Turned it around pretty well, came out as we like it, but our focus here is going to be on thermal and power first and foremost, because the one thing this has going for it within the pricing spectrum is that it's a flagship, ultra high-end card, so everyone expects that the value is going to be bad. That's just how it works. From that angle, there's still some fun to be had from this being an enthusiast card, which is why we're doing all the overclocking with it and the focus on things like power consumption. Additional things you need to know: it's 24 gigabytes of GDDR6X memory. It's a 384-bit bus, and then for the die, it's GA102-350 for the silicon, with the TDP at 450. I didn't know I put this many in there. They kept coming out. For the rest, NVIDIA's marketing is largely focused on 8K. Well, largely. It's about 30% 8K gaming. So they backed off a little bit from the mockery of the 3090, where NVIDIA torpedoed its own launch on that one by focusing on 8K gaming as if that's a thing anyone gives a shit about. But it's also talking about being a creator card. We actually don't disagree with this aspect, because the 24 gigabytes of memory is extremely helpful for our workloads and working on what now everyone calls content creation. So we use Unreal Engine 5, for example. We use it for visualizing our office. We use it for building out animations these days. We've largely replaced Blender's rendering with real-time rendering in Unreal Engine, and the memory does help there. We use 3090s for that. So we can see the value. We get it. For most people, of course, these flagships should be, in a way, considered to be Titans. They should probably rename so that NVIDIA doesn't bear the expectation of being a gaming card that is granted by a non-Titan card. But they should be thought of the same way. Now, ultimately, this value is atrocious. It's terrible value versus the 3090. It's the same memory capacity. You don't gain much, 8 to 12% like you said. And really the takeaway is that the memory moves all to one side of the PCB. That's the value here. So there's not a lot of value outside of that. It's easier to cool, and that's kind of it. Anyway, let's get started with the benchmarks. We have a lot to talk about for testing, and then we'll go through a little bit more of the conclusion, but you've basically gotten it here already. Power consumption testing is up first. We're front-loading this because the card is so impressively power hungry that this test has actually become really interesting. We have no doubt that transient load survival is going to be one of the hardest tasks for power supplies to keep up with the 3090 Ti, but that's harder to test in a short review window. In the very least, we can start with raw power consumption in a torture workload. The total card power draw of the RTX 3090 Ti FTW3 was a shocking 500 watts. Running 2 of these with anything else in the computer at all would put you into dual power supply territory on a 115 volt wall drop. So we're truly back in the era of ultra high power draw components. The GTX 480s would be proud of this one. It's like true to form for older style NVIDIA. Now the big difference now versus then is that cooling has become far more advanced, but mostly at the cost of form factor. That's why this card is so fat. The OC VBIOS pulled the same 504 watts as it only adjusts for fan speed. The power consumption versus the stock 3090 non-Ti, also FTW3 previously, at 389 watts, is 29% higher with a 3090 Ti FTW3. That's going to set the tone for this entire review because it sets the tone for efficiency, or the percent improvement for the percent increase in power draw. Overclocking the 3090 Ti got it up to 533 watts, in line with the 7% power target offset. But take a look at this chart. The per rail power consumption looks like this during the overclocked testing. The total power consumption maximally spiked to 560 watts, but it may have spiked even higher if during microbursted transients, which typically are up to about 100 microseconds in length. We can only measure 100 milliseconds with this particular equipment, although we're working on that, but the sudden drops in the total power consumption seen in this chart are from stability of the overclock. It was actually somewhat difficult to stabilize this card under some conditions, like torture workloads, but more on that later in our overclocking section. The PCIe cables fairly universally ran at about 180 watts each. We'll plot them one by one here. That makes sense because they all feed into the same single 12-pin connector ultimately. The PCIe slot is capped at 66 watts at 12 volts and 75 watts total for the spec, and we're well under those numbers here. The card is primarily leaning on the cables, which is sensible when there are 3 available, all plugging into an octopus, but the slot draw was 10 watts on 12 volts and about 0 watts on 3 volts. Our thermal testing is extensive on this one, but we'll split it into 2 charts, and we'll start with the simplest one. Equilibrium temperatures for the GPU core, GPU hotspot, and memory, tested across all 3 VBIOS options, is what we're looking at first. The VBIOSes on this card only adjust fan speed, not the power limit, which is capped at 480 watts, so we'll look at that next. In the slower RPM normal VBIOS, the card ran well within acceptable tolerances at 70 degrees Celsius core and 79 degrees on the hotspot, with ambient temperature at 20 degrees Celsius, but this is not delta T over ambient, this is just the temperature of the card at 20C for ambient. The memory thermals averaged at 71 degrees for this VBIOS. The performance VBIOS is the default EVGA choice though, and this one had us at 63 degrees, 71 degrees for a hotspot, and 64 degrees for memory. The OC VBIOS has no meaningful impact on anything in our testing, and doesn't even look like it's changed anything here. The chart we're showing now is for an AMD CPU actually, but it's helpful to illustrate this next point. As a reminder, GPU thermals directly impact boosting frequency. Every couple degrees Celsius can be the difference of maybe 12 or 15 megahertz on the clock for most cards. But these really fat, high-end cards can normally flatline the frequency. The NVIDIA behavior is more nuanced than what we saw in that AMD chart, but modern AMD CPUs behave in a similar fashion by leveraging additional thermal headroom to boost higher. Here's the frequency chart for the 3090 Ti. The normal VBIOS has us at about 20-25 megahertz dead for most of the test, although it peaked at 20-40 megahertz at the start, proving the point on how a couple degrees results in that 15 megahertz reduction we saw. The performance VBIOS runs a slightly higher clock at 2040 for the full test. That's not for any reason though, other than the more aggressive fan curve programmed into VBIOS. For the OC VBIOS, without any overclock actually applied, frequency starts at about 2055 megahertz, but settles at the same 2040 as performance. The flat line is somewhat remarkable here. NVIDIA FE cards typically have much more chaotic frequency plots, as do lower end board versions for almost any GPU. That's because they're more power limited for the target. Here, EVGA has boosted its power target enough that the common limiter is VREL, or voltage, not power. If you were to boost voltage externally or through a mod, the cap would become power or thermal instead. So VREL, or voltage, is the reason we're stuck at this flat line, but the flat line's a good thing. Fan speed is the next most important part, seeing as it's the only thing that changes with these VBIOS options. The normal VBIOS has us at 0 RPM and boosts to about 1657 RPM over sustained load. Hysteresis has us at about 383 seconds required to stabilize the fan RPM against the VBIOS temperature target. The performance VBIOS jumps nearly immediately to 1980 to 2000 RPM under the same test conditions. Hysteresis, or fan ramp lag, is closer to just 200 seconds to ramp. But the jump from 0 to 1800 takes place in about 2 seconds. That's very noticeable to the end user and will be more audible than the curved ramp of the normal VBIOS, which only instantaneously jumps to about 1200 RPM. The OC VBIOS doesn't seem to do anything different than performance VBIOS, but remains useful as a switch for flashing hacked VBIOSes onto later, like for XOC. So the main takeaway here is that you can run this card sized such that it is at a much lower RPM of about 200 to 400 RPM reduced off of the automatic speeds we're seeing and still be within an acceptable thermal tolerance. And what that allows you to do, obviously, is just have sort of a better user experience without really giving up very much. It's still well within acceptable range. The frequency doesn't change much more than 15 to 25 megahertz max, and that's kind of what our recommendation would be if you were to buy one of these cards, or really if you buy anything that is sized like this on a lower end card as well. The other takeaway is the opposite end. There's room to ramp the fan speed, and there's room to leverage the thermal capabilities of the cooler for a bigger overclock. But if you're going to do that, really you'd need an unlocked VBIOS where the power target is uncapped or at least capped higher. Right now it's capped at about 480 watts stock, and you do the 7% offset, and that kind of limits you. So we're seeing max 500, 530 watts, somewhere in there for total board power, and that's just not enough to get really much more out of it. So you would need a mod for that to go further. And finally, this is at least showing that this cooler is attached to the components and cooling them properly. We've seen other massive cards in the past, like the Zotac 1080 Ti, where it has this huge cooler, but it's not really connected to anything except the GPU sometimes. So it is at least being leveraged here. Now for the memory and voltage regulator module thermals. This is where things have historically fallen apart for the non-Ti 3090 cards due to low heat sinking capability of the back of the PCB. For this one, using the hottest VBIOS as a measuring stick, the tested memory modules never exceeded 67 degrees Celsius on the NTC thermistor logging the data. This is well within spec and is a relief as compared to the original RTX 3090s. Although the price is extreme. The VRM components never exceeded 65 degrees Celsius during testing, which is also well within spec. These could scale up to 100 degrees Celsius and still technically would be within spec, so there's a lot of headroom here. EVGA has built an insanely overkill cooler for an insanely overkill price. Okay, next we're going to talk about overclock, performance, and stepping. The really important thing we want to lay out here is that as you're overclocking, you have to do validation. So it's not good enough anymore to just run it with the core offset, the memory offset, and do that until it crashes. Now, once you think it's running stable, you also need to do a performance check with something like Port Royal or a game that's repeatable, anything that gives you a repeatable score, because if that's not done, then what can happen is silent memory errors in the background that would actually produce a lower result than stock. We've seen that. It's possible to think you've overclocked your card, but actually you've just hurt performance worse than stock because it's not crashing, so it doesn't present a catastrophic failure, but it also is silently failing. Each application will behave differently here, so you want to tune for sort of the most fussy of all of them. And then for frequency, offset, and power percent, remember that these are always relative to what the card is doing anyway. So if one card has 115% power target, the other one's 107%, it doesn't mean that 115 is higher than 107, other than as true numerical value. Because if the power of one is 480 watts and the power of the other one's 450 watts, obviously the percentage means a different thing. Here's the stepping when using Port Royal to validate. We had already determined that 125 megahertz offset was the most reliable for wide-reaching stability in various games, so we settled there. Although it sometimes could hold 160 megahertz offset in Time Spy Extreme, that would not hold globally, and especially not in games, so it's not really valid because it wasn't stable. First off, we notice that the EVGA precision voltage slider actually does something here. The slider helps stabilize the maximum frequency without any other changes, and you can see that when our limiter switches from VREL to power. The frequency jumped up by 15 megahertz just by moving that slider and changing nothing else, which also allowed an immediate jump in score from about 15,480 or 15,490 maximally to about 15,520. That's an increase of about 0.25%. And if you've seen our extreme overclocking streams, that's actually a pretty big jump for just doing one slider from 0 to max. This slider only tells the voltage to run at its peak available option consistently, so it can be thought of more as a binary switch than an actual voltage offset. It is not offsetting voltage by 100 units of anything. It's just kind of fully offset to the peak or not. From the stock 14,880 result on normal VBIOS up to the max 15,549 score we got with our heavier OC, we got about a 4.5% uplift overall. It was about 2 hours of work to get this stable and operational. We'd say that this generally isn't worth overclocking today, but we've seen cards in the past like the 1080 Ti or the 780 Ti or 980 Ti where overclocking becomes disproportionately valuable as the card ages. We don't know if that'll be true here though. In other words, 4.5% today in today's applications may turn into 7 or 10% in the future. Either way, the overclocking aspect is clearly more fun from an enthusiast tinkering standpoint than it is from a practical one at 4.5%. In Shadow of the Tomb Raider at 4K, the RTX 3090 Ti FTW3 stock card ran at 119 FPS average, leading the original 3090 FTW3 by about 12%. That's with brand new data, too. We reran another 3090 and got about the same averages as we did previously. The end result is 2.5% more power consumption for about every 1% more performance, showing that we're beyond the operating point for efficiency. Overclocking the 3090 Ti certainly doesn't help that argument, but it did boost the results by 5% average FPS while maintaining good low FPS consistency. The 6900 XT runs at about 98 FPS average here. That's too bad because the human eye can only see above 100 FPS. So this card is best left to the poors and the peasants. The lead over the 6900 XT is about 21% at 4K in this game, though this would reduce as we approach lower resolutions, but there's obviously a limit to how low of a resolution you'll go with these cards. At 1440p, the results had the RTX 3090 Ti FTW3 at 176 FPS average, with lows still in good shape for overall frame time consistency. That has the 3090 Ti leading the 3090 FTW3 non-Ti by 3.7% in exchange for 15% more money, comparing FTW3 to FTW3. The 6900 XT encroaches here, but we're predictably limited by the CPU in this set of data as well. Clearly, in terms of value, you really shouldn't be buying either of these cards for gaming. That's not news. We've been saying that. They don't make any sense for the vast majority of use cases. The 3080 or the 6800 XT achieve most of the performance for a fraction of the price, even factoring in scalped prices. This isn't news to NVIDIA either. They're trying to distance themselves from the gaming marketing for these cards because it worked out very poorly last time when they tried to make it a whole big 8K gaming thing. Anyway, these are more worthwhile if you need the VRAM, like we do for some of our Blender and Unreal Engine workflows, but because NVIDIA shipped these out with sort of 2 days of notice, there wasn't a whole lot of time to factor that in. Total War 3 Kingdoms is run at ultra settings in our test suite, which makes it one of the most abusive benchmark scenarios that we run. The RTX 3090 Ti stock card plotted at about 60 FPS average at 4K, which gives it a 10% lead over the RTX 3090 Business Casual FTW3. The overclock pushes another 3 FPS average, not noticeable to a human at this level, but probably noticeable to whatever this is. The lead over the RTX 3080 is about 26%, with the 6900 XT roughly in the same spot. Ultra settings at 4K are ridiculous, though. You could easily make this playable and enjoyable at 4K with these cards by dropping settings one run. We leave them high for the value of creating a strain for showing scaling, though. At 1440p, the 3090 Ti FTW3 ran at 116 FPS average, still constrained by the game more than the CPU and the RAM. The lead remains about 8%, not as much as before, but not bound either. The lead over the 3080 is about 13%, so not particularly worthwhile going much above that. At 1080p, we still see scaling thanks to our aggressive settings for this one. The 3090 Ti FTW3 ran at 161 FPS average stock, lows paced as we'd expect, and well, with the OC giving us 7%. That's one of the best gains from overclocking we'll see on this card for the whole review. It's not particularly impressive, but it's better than what we saw elsewhere. The 3090 Filthy Casual Edition wasn't much behind here either. In the Division 2 at 4K, we measured the RTX 3090 Ti FTW3 at 133 FPS average with lows paced in accordance with other frame time consistency pacing on this chart. The overclock boosted us by 5%, consistent with previous results up to 140 FPS average. Compared to the RTX 3090 Master that we just reran tonight, the lead is about 16.5%. The 3080 Ti still sits behind that, with the 3080 Eagle at 105 FPS average, about tied with the 6900 XT. For reference, the 3090 Ti leads the 3080 and 6900 XT by about 27% in exchange for the massive price increase. Again, even at those scalped prices, gaming is best done on cards at or below the level of a 3080 or a 6800 XT, which we're only really saying just in case some of you are newer here and haven't been in the market for this cycle to know that. At 1440p, the RTX 3090 Ti FTW3 and the overclocked results align with no difference as they bounce off of other limitations. The leadership over the 3090 is reduced to 9% due to this limitation, so there's not much to learn here other than, as we already knew, running at lower resolutions and settings won't be benefited by extreme graphics processing capabilities at all. Now, AMD has maintained an advantage as the resolution goes down to 1080 or 1440 price to price in the past, and that's true here as well if you remove the CPU bind. The 6800 XT and the 3080 are in the 184 FPS average range and are more than capable here, with the 3090 Ti leading by 19% as capped by other devices in the system. In Rainbow Six Siege, the RTX 3090 Ti FTW3 ran at about 239 FPS average, and we see there's still plenty of scaling room by the OC, landing at 249 FPS average. That's a 4% uplift, which still doesn't feel particularly worth it for the effort, but considering the level of performance this card is already at, 530 watts, there's not much more room without just committing to competitive overclocking. The 3090 FTW3 allows the 3090 Ti a lead of 12.3%, about in line with our previous results. For perspective, the 3080 manages 80% of the 3090 Ti's performance, in case that's helpful in making your choices later. At 1440p, the results boosted to 417 FPS average when stock, or 430 overclocked. There's still sufficient room to see scaling at 1440p with these graphic settings as well. The 3090 Ti ended up leading the 6900 XT by about 18%, with AMD gaining some ground as resolution drops. The 3090 Master is led by about 10% in this one. For one last benchmark, we'll look at GTA 5 at 4K, really just for fun. With our test settings, this old game remains challenging for GPUs to run at 4K. The 3090 Ti FTW3 capped out at 126 FPS average, again with good load timing, while the OC pushed 5.4% ahead. The lead over the slovenly 3090 non-Ti Poor People Edition is about 10%, once again showing that the average gap is consistent across games. Okay, so as noted, we were trying to sort of respect everyone's time and just put it all up in the front of the video. You get the idea. The increase versus the 3090 is about 10% plus or minus a little bit. Increase versus the 3080 is sometimes 19 to 27% depending on the application of the game. And 3080, 6800 XT, really we're just re-emphasizing this point for people who might be new to building systems, new to the market, haven't been in the market for a few years. The maximum card you need to be looking at for a gaming computer really stops at a 3080 or 6800 XT, and our original reviews for those largely stand. The numbers have shuffled a little bit with drivers, but the concepts are the same, and when you would buy each one remains the same. So that's where you need to stop looking if you're buying for gaming. For 3090 type cards, I mean, the 3090 when it came out was an absolute mockery of a card. It made a buffoon of itself. NVIDIA made a buffoon of itself by doing the whole 8K gaming push, doing 8K sponsored content before the launch of the card, and trying to present it as if that's even remotely realistic as a wide sweeping thing. It's just not. Don't expect that. That's stupid. And we're not there yet. And that's fine. Not many people have an 8K monitor or TV or whatever. So it's just a silly, irrelevant marketing point, but it's still there on the slides as if NVIDIA couldn't be like, reducing the focus to 0% isn't enough. We need to still look like we're committed to this idea. So let's do 30% focus on it. The rest was on content creation. There's some gaming discussion. So it stacks up like this very simply. The card, as it is from EVGA, is well built. It is an atrocious price at $2,200, but this is not surprising to anybody. The thing that is a little more surprising is the power consumption at 500 watts. This changes the landscape for the class of power supply you have to buy at the high end. And more importantly, transient load spikes are a massive consideration for the 30 series, and they will be for the 40 series as well, from what we're hearing at least right now from the power supply manufacturers. And transient load spikes is something we're actually working on doing some testing with this particular card, but what you need to know is that these are things that sustain for maximally something about 100 microseconds, and it sounds really short, and it is, except with a lot of power supplies, including some of Seasonic's higher end units, a lot of 850 watt gold units, 1000 watt gold units, a transient spike of a couple X, the expected power consumption, or even a couple hundred watts over, not necessarily full 2X or something, that's enough to where if the power supply doesn't have enough capacitance to soak the change, you lose power. And the system will shut down from functionally an OCP, or overcurrent protection. So that's what you need to watch out for. We did not run into that issue with this test setup. We were using the EVGA T2 1600 watt though, which is absurd. I mean, that's a lot of capability from a power supply. So we're working on a follow-up content piece to look at that. This has been an issue with the 30 series in the past. We haven't seen it yet on the 3090 Ti because we've only had it for 2 full days of testing, and we didn't spend any of that on transients. So anyway, something for you to be aware of, where this is a gap in our testing coverage that we are working on filling over the next few days or a week or so. So we can't include that in the conclusion here. Ultimately then, obviously, like the Titans have been for us in the past, this is largely a probably don't buy this. We do see the value in content creation because we've used it that way. The price hurts a lot. If you're making money on it, then it's kind of like business class internet, where they say you could have consumer internet. Actually, you can't, because you're a business. So you have to pay business class rates, get basically the same thing that used to be available for consumers, but you pay a lot more. That's kind of where the 3090 Ti slots in, where if you're a professional, especially if you're making money, it starts to get easier to justify, but it still hurts in the pricing. So for us, a hard pass on this. 8 to 12% for $2,200 is insane. The only reason that cash grabs like this and the 3080 12 gigabyte can work is because if you're new to the market, and they know this, if you're coming to the market and you need a video card and you see the 3090 is out of stock, but the out of stock pricing says whatever, $2,000, which is the current price, $1,920 is the price of the EVGA FTW3 3090. You see that, and you see the new one for $2,200 or something, $300 difference. You've talked yourself into already $2,000. So now you're like, what's another couple $100 to just get something and be done with this? And that's kind of the market we're in right now. Everyone knows that. We've said this for many months at this point. It is getting boring from a content perspective, but it remains the reality. So we do want to put that out there. But the power is really, we think, the main story here at the incredible 500 plus watts. So that's it for this one. Check back for follow-ups as always. Again, 2 days with this, full days. We are exhausted and tired, but we got through the review. I'd like to do a lot more depth to it, but that's the limit of what we can do and still hit embargo, which we have a responsibility to do to make sure people are informed as soon as this thing goes up. So that's it for this one. Thanks for watching. We'll see you all next time.